Hi guys, welcome to Learn Electronics Repair. Another speaker, so amplified speaker, Opera 510DX, DB Technologies. So built-in amplifier, active speaker, and I have two of these here, a matching pair, but they don't quite match because one of them works and one of them makes bumping or popping noises, I think is the way she described it to me, and this is the one that makes the noises. So it doesn't like go bang or do anything drastic. So in this instance, I think I'll actually just plug this one in and see what happens. So I have the current, let me just switch to mains. It's not in circuit. Turn this on. Turn this on. And, oh, the green light comes on. Ah, listen. It's got its own built-in rhythm section, okay, so that's the fault. Quite clear on that, even without a signal attached. Let's see if we can figure out what's causing that. Okay, so it's clicking. Let's see where that's coming from. So if I just disconnect the horn, which is here, so this goes to the tweeter, and actually no, this goes to both. Okay, well let me disconnect the speaker. So I've disconnected the horn. What happens? We still have the ticking noise. Okay. And that went tick when I plugged it back on. Huh. Okay. It switched off, so there's obviously some voltage in the capacitors. Let's disconnect this sub. Okay, I've disconnected the sub. I'll reconnect to the horn. Let's try it again. So this is just the horn. And it doesn't do it. Okay, so the sound must be coming from the bass speaker. Disconnected, the sound stops. Right, let's have a look at this amplifier. Well, there's only a small heatsink on this, and this is plastic. So this must be Class D amplifier with linear power supply by the looks of it. Let's get this heatsink off and see what we have. So we have like a metal block on here. The heatsink was fixed there, or at least the metal plate. The power devices are kind of down under there, so this unbolts from the other side if I want to get to it. Okay, two of these chips here, are these the like ICS 2092 type things? No, they say something like AEBOP1 377P. 337P rather. Okay. I have this DigiPro 200B, so let's have another look for a schematic. Okay guys, so I've tried that number, I've tried PST410E. I also noticed there's another marking here, DigiPro G2, so I've searched for that as well, plus the Opera 510DX, and I can't find an actual schematic, but I found something that may be close and might help. And the one I found which is close is this one, so PST417C minus PST410E. This is a DigiPro 600B minus a 200B, but I'm hoping that one is maybe just a higher powered version of the other, and there's enough similarity here to help us. What I can see straight away is these chips here, AEBDP1, AEBDP1 again, so this is U3 and U7. And looking on my board, I have U3 and U7, what I thought are probably the kind of all-in-one Class D amplifier chips. Not IRS 2092, but something like. And then we have MOSFETs. I've taken the heatsink off, so MOS 4, 3, 2, MOS 1, okay. And again, that matches what we have here, so MOS 1, MOS 2, MOS 3, MOS 4. So it looks like there are some similarities. Let's see if we can find a data sheet for this chip as well. So this AEBDP1. Okay, I can't find the datasheet. I found this. Somebody suggests it's a relabeled IRS 20955S. Sort of something like I thought it would be. But I think we have enough information to be able to look around this. I'll put the heatsink back on the MOSFETs for now because I don't really need to probe under there. And let's have a look to see if we can work out where the clicking starts. Although being feedback in an amplifier, that may not be quite so simple. Okay, some basic checks first then. So we have power with a center tap and we have power. So one's going to be like the high voltage power, probably this one. It says HV, so we'll go with that. LV. We have some diodes here. So this is going to be a bridge rectifier. So I can see cathode, anode, anode, cathode. Probably, we'll soon find out. These two cathodes, if they connect to each other. Yep, so that's the positive output from the bridge rectifier, which is made from 4 diodes. That's the negative, so we have plus and minus we can measure here quite easily. Then we have, these are look 79MO8 and 78MO8. So these are 8 volt positive and 8 volt negative voltage regulators, so we should be able to check these to see if they are working. So we'll have plus and minus whatever, plus and minus 8, and then we have some bigger chunkier diodes here. So we have the 2 cathodes. I just want to find 2 cathodes that are connected to each other. Well, those read short, but that's where the wires come in, I think. Let's have a look. Now, one wire comes in here. This one probably goes to the 2 anodes. There's a cathode. Just trying to figure out where the output is from this in actual fact. In fact, I need to just double check that one. Because with the winding attached, they'll all read short. So we'll disconnect that. I say all read short, I mean the AC inputs will read short. Let's disconnect this one. Okay, we can leave the ground attached, not a problem. Right, let's just check again. So, cathode of this one, does it go to the cathode of the other one? No, you see I was confusing myself. No. No, interesting. Well, one cathode must connect to another cathode. This one and... oh, is it these two? So we have a cathode here. And we have a cathode here. They connect together. So that's the positive out. And then here, yeah, that's the negative. Okay, so this end, plus minus. I have to disconnect the AC so I can see it. And then on the other one, well, we have 2 cathodes here. Connect to each other. And 2 anodes. In fact, there's test points, Luke. There's a test point 17 and 18. Of the supply. Okay, so we can see where to test for the voltages. Okay, all right, let's reconnect the transformer, power it up, go to volts. So we just check it should come on with the green light. Okay, all lights on, green is on. Obviously no speaker attached, so it's not clicking. Right, what do we have? So, from ground, plus 53, minus 53. Is this one also symmetrical on ground? Let's look. Minus 17. About the same. And then on the voltage regulator, so the output of the positive one is here. 7.9, we'll call that 8, okay. Then the output of the negative ones is here. Yeah, minus 7.9. So we know the supply voltages are okay. So let's kind of split this in half. This effectively is the analog input side of the amplifier. Now we have a switch that switches in or doesn't switch in the digital signal processing, which I'm pretty sure is this thing. We can set the audio to flat or processed. So I think that's this switch by the looks of it. So let's see. Well, mine does differ in this respect. This schematic has 2 push button switches, switch 1 and switch 3, with pins 1, 2, whatever, and repeated here. So that's different. Let's hope other parts are the same. So it looks to me like we have audio coming in this way through this op amp. That's the volume control, I would say. Audio in, test point, and then that, regardless of this flat or processed, at least on mine, goes here. Yeah. As I say, there may be differences there. We then have some op amps here, driving channel 1 and channel 2. And then we come to these chips. Now, I have these chips on my board, and we can see pin 3 is the input, which goes to U4A. So this is a dual op amp, half of it, U6B. And it's a bit tricky to probe on the actual chip. It might be easier to probe here. So I want to have a look to see whether these clicks appear here. Yeah. So is there something that's getting into the Class D amplifier? Obviously it amplifies it, or is it something that the Class D amplifier is doing itself, one of them, okay? So I can test to see if this matches my PCB. If I find these chips, U4A, U6B, we have pin 1 and pin 7. And if I can see 1K resistance from that pin to pin 3 on this chip, I know it basically is the same on my PCB, okay? So here's U6, this is pin 1, it's marked on the silk screen. So pin 7, that's the output, and that is it 1K to here. I'll just go on to resistance range. Yeah, it reads 1K, the nearest, damn it. Okay, and pin 1 on this one, which I think is here. Can't really see the silk screen, but it looks like a flat edge. Pin 3. Yeah, the same. So that looks to be the same to me. And then we have the resistor R68 and R33. That's probably a nice easy place to probe, to be quite honest. Well, there's R68. Yeah, we connect to there. So we can easily probe here. R33 from pin 1. Although that's easy enough to probe, to be honest, on this one. All there. Okay, so we can probe here, or we can probe here. And we can probe easily here. Okay. I generally find an analog scope better for these kind of intermittent signals. Just easier to see them. So I do have the ground attached, by the way. I have another clip, so I have ground attached here to my scope. That means I don't have to have a ground on here. If I'm in high voltage circuits, I will also take this off as well, actually. And then it can't catch the back of my wrist. Yeah. Not that that ever happened before. Yeah. And I learned that the hard way. No. So, pin 1. Okay. We'll power this up and let's see if we get any sort of pulses. I mean, I don't know if this one or this one is the amplifier that's got the clicking on. Okay. The sub or the horn. So, power it up. What happens? Well, I've got no speakers attached, so we can't hear anything. This just goes low. At 5 volts. And the other one is on this resistor here, R68. And I don't see anything there either, any clicks, okay? I'm going to attach my speakers to this, so at least I can hear the thing. And then we'll just try that again. This is where having a variety of connectors comes in. So these are like the spade terminals onto a connector block. This one has two 2-pin ones, but these can be pushed together, so you can put them onto a 4-pin like so. Okay. And then above my bench I have 2 speakers I'll show you in a moment. And these are the speak-on connectors, so these on quite, well, a couple of 3 meters of wire each. And I leave these sort of coiled up by the speakers when I'm not using them on the shelf. I'll show you where that goes now. Okay, so you can see one of them is there, and the other one right across the other side, but it's there. Okay, those are the little things, by the way, you can just see up the top there, white and black. I have a couple of 100-volt speakers for, like, you know, 100-volt line stuff. So those are the speakers I use. These are actually jukebox speakers. And then I have a couple of these made from mains cable. These are speak-on sockets, so I plug the speakers into these. And the other end are just bare wires, which I can attach to the various terminal blocks. And that's how I attach various things onto my speakers, depending on what I'm working on. So these connectors are just taken from scrap things. And I have a variety of different size ones, for example. So collect those things together when you get something scrap. They're really useful, guys, okay? So let's connect this up so we can hear the clicking and have another look. I'll be able to hear which speaker it is. You guys obviously won't because it's a mono microphone, but I'll be able to hear, so let's try it. And it's not ticking. Oh, it is ticking. Okay, so it's the right-hand one. And it's gathering speed. Okay, let's have a look. So that's this one, pin 1 U4. Ah, and we can see it. Yeah. You see that spike occasionally? This is why an analog scope is much better for this sort of thing, guys. You don't worry about triggering. You can quite simply see it is there. Okay, so the problem is somewhere on the first half of the amplifier, I would say. But I need to just check one thing. So here is where I see these pulses. Pulse, pulse, pulse with the clicks, okay? And one could assume that means that the problem is somewhere back here before that point. But that's a kind of a beginner's mistake, because the problem is, if you look at the amplifier, these are your 2 MOSFETs. This is your output, which goes to the speaker. Okay, your speaker goes on here. And look, we have a connection from here, back along here, through these 2 resistors in parallel, back along here, feedback to here. So, the problem is that where we see the click here could in actual fact be caused by something after there. Do you see that? Because if the filters, for example, here, it's just feeding it back to here. It's a loop. Yeah, it's a loop. What we can do, though, is go back a little bit further to here or here, because this is outside of that loop. Yes, there's a resistor and a capacitor to here as well, but this is outside of that loop. And I'm interested to see what we have here. If we see those pulses here, for example, we know it's definitely something in this lot that's causing it. Okay, so let's have a look. So U8 pin 1 and U4 pin 7. Well, we know where U4 is. Okay, and there's a test point by it, so let's have a look. Well, here we obviously have U4. We were looking here before, and I've just noticed that, and also that as well. So, is that a bad capacitor? Has that just got paint or something on it? It's in this area of the circuit, C20. Well, actually, it's a decoupling capacitor to ground from low voltage plus. Okay. So it's not in the signal, it's a decoupling capacitor. Let's have a closer look at it. Well, that does look like it's burnt. And also maybe charred this or smoke. So we have this track up here, sorry for the vibration. There's another one there. And this looks like there's a bit of damage. Right, let's clean this up with a bit of ISO. But just before that, this is the other amplifier, and that's effectively the same capacitor there and there on this one as well. And this channel works, or rather this amplifier works, okay? Right, I'm going to get this cleaned up and let's have a look. Actually, when I say this amplifier works, assuming this is the tweeter amp because it's not going click. It wasn't going click before, but not going click and working is not the same thing, yeah? So maybe it is also faulty, just in a different way. Maybe both are not working. On this amplifier, which isn't clicking, we have C90 there as a black colour and C87 as a black colour. Let's see where they are. C90, and it's searchable, that's good. So C90 LV plus to ground. C87 LV plus to ground. So they're on the same voltage rail. And the other amplifier, just C20. I mean, that's got a bit black on, but I'm not sure if this is what it is on these. It seems to maybe come off. Bit unsure about that. Maybe it's actually just paint, you know. We'll measure the voltage on the rail. So C20 is on the same voltage rail, okay? Let's measure these voltage rails. It should be quite easy where these capacitors are actually. And also on the op amps, pins 4 and 8. 8 volts. No, we had an 8 volt regulator. We know we have 8 volts. Minus 8. Plus 8. So the voltage rails are fine. So those are not short. I think it's paint on them. Looks suspicious. Okay, so let's continue on the route we were originally on. So U4 pin 1, this is where the clicks were. U4 pin 7, which is outside of that loop. But what's just occurred to me is when we had the clicks on here, when I put my scope probe on, it went down to a negative voltage and then little clicks going upwards. Now, you would assume, or I would assume, that if there's no audio input, then that basically should be 0 volts. It should go positive and negative with the waveform. So the fact that seems to be, I was on 5 volts per diversion, so probably down towards the -8, which is the supply to this, tells me that this is kind of like offset where it shouldn't be. So do we have an offset here? Yeah. And we can just compare that actually with the other channel. And just note the other way around. So U4, 7, and then 1 is the other output. And on this one, U6 is 1 and then 7 are the outputs, okay? Well, we write by U6 anyway, so let's start with this one. This is the channel that doesn't click. So pin 1. You see that's 0. This one, pin 7. Has like some sort of oscillation on it. That will be coming back from the pulse width modulator. Basically 50-50 duty cycle. So that will be coming out of that chip. That's what they do when there's no signal. And this one, pin 1 is the output. Look, and it's just negative with the clicks, yeah? See it? And pin 7 is basically 0. Okay, so this signal on U6, output 7, U6B, this had that high frequency oscillator type thing on, and this one just went down effectively to the minus rail, LV minus, which is 8 minus, okay, with the clicks. I'll just show you why that's happening on the good channel, why we have that high frequency signal, because if you're not familiar with these Class D amplifiers, you may not have expected that, but once I draw this on a piece of paper, you'll know exactly why we should see it. So, a basic diagram. We have an op amp with the audio coming in. Okay, so this is your audio signal. It actually went through a capacitor and a resistor, but that's not important to this description. That goes into another op amp, and then the output of this goes into this chip. Common ones for these are IRS2092, but ours isn't that one. It's AEBDP1, but it's something very similar, maybe even a remarked one of something like that. Okay, and then this drives two MOSFETs. So this thing basically is an all-in-one Class D amplifier, and the two MOSFETs are basically wired like this. This is HV plus, this is HV minus. These chips run on LV plus and LV minus. Okay. So this is your plus and minus 8. This is a high voltage. And then from here, basically, we have an inductor and some stuff. But this goes to your speaker. Okay, and your speaker's connected from there. Your speaker connects to ground. So the Class D amplifier uses pulse width modulation. So you might think that with an amplifier, when there's no output, so the speaker cone is in the middle, it's not moving one side or the other, in or out, that both of these transistors are switched off. And in a Class AB analog type amplifier, that is true. But in a Class D, that isn't true. What happens is that these are running at high frequency at a 50% duty cycle, okay? And they're running alternately. So effectively, this one switches on or this one switches on backwards and forwards. Okay, and if they are both effectively switching on for the same period of time, yeah, then the voltage here will be halfway between HV plus and minus, which is 0 volts. So the speaker cone is in the center. And if this one starts running at a wider duty cycle, so more on than off, yeah, and this one is running at a low duty cycle, so more off than on, like so, probably not anything to scale. What happens is there's more positive than negative, so this end of the speaker goes positive with respect to ground and it moves one way, and you can imagine in the other duty cycle with this one wider than this, it goes more negative and the speaker moves that way. So that's how it works. But the main thing is that when the amplifier is idle, it's oscillating at high frequency with a 50% duty cycle. And what we can see coming back this way via a couple of resistors, whatever the network is the feedback that sets the gain of the amplifier. So some of that oscillating thing appears back here, and that's why on the good channel here I can see a very high frequency oscillation. Okay, here I don't see it, I just saw a level DC 0 volts nothing signal. On the bad one, this here is actually going down to minus 8 volts, and I don't see that. So that tells me that A, this isn't oscillating because it would come back to here, and B, this has gone down to the voltage rail. Now, could be, I guess, a problem with the op amp or a problem with this. So what we're going to have a look on the bad channel on the speaker output here is whether or not we have any oscillations. If we don't, then I'd say this is the culprit. And if we do, I'd say there's something wrong with this feedback, yeah, or with this op amp. Let's have a look. Okay, so we need to look at this oscillation from pin 13 here, this side of the inductor and capacitors, because these are there to filter out those high frequency oscillations before the signal gets to the speaker. So easy way to test, because these are big 1 watt resistors, says 2K2, 1 watt. There's 2 of them, it's here. Looks like I have a 1K, just one of them. But we can soon find if that's the equivalent on mine. I'm in ohms range, so the resistor reads 1K. And if I go to the speaker output, one side or the other, whichever is the positive, this I think. Yeah, that goes to the resistor. So this is where we're going to have a look to see if we have the oscillations. Okay. Well, I don't see any oscillations there. The clicks are there. You can see them occasionally. So I'd say quite simply, as far as I can tell, but obviously this is a closed loop with a few components. Probably that chip isn't running, or it could be a problem with the op amp, but it's a bit hard to say because of this closed loop. So I think the easiest thing to do, because I don't have these, is to swap this chip and this chip over and then see if the fault goes to the other channel. And if it doesn't, then we'll swap these two over, okay? Because they're the same chips. 33078 looks like. 33078 will be. Okay, so I think this is the more likely of the one. I mean, it could be caused by something else around this chip, but we need to sort of eliminate a few things now, really, to pin this down further. So, easiest one is to swap those chips, I think. I've taken the board off to desolder these. I'm just looking at this, so you see like a blob of paint there and 2 blobs there, and these components are missing. At first I thought, oh, was that broken off? But I'd say these were never fitted. I mean, they're both missing to start with, and I don't have an exact schematic for this either, to be quite honest. The only reasonable way to do this, I think, is with hot air. There are some large capacitors, but they're out of the way down there. These are inductors, there are these connectors. They're hopefully out of the way in this direction enough. So I'm hoping I can desolder these without damaging anything. It's always a risk, of course. And because I don't have any, I'm going to take them both off and swap them over. It would be nice to think, well, I've got one, so I can just take one off, but it's not happening. And I'm not even sure at 100% it's faulty. So we had leaded solder. I'll try the little Sugon C210. It's quite fine. Let's see if this can get enough heat into this to actually add leaded solder. Yeah, it did, and it saves me getting the big chunky tip down here because it's a bit crowded, shall we say. Okay. Let's go with the other side. Okay. I might as well get the other one ready as well, so while the board is warm, I'll do this side also. Actually, you know, this might be quite tricky because it looks like all the components are glued down, which suggests very much to me that this is glued down as well. And if that's the case, hot air often will damage the PCB before you even get the thing off the board. I'm wondering, can I get it off with the tweezers? I'll warm the thing up to some extent anyway, just to get the area warm. So I'm basically just getting the whole thing warm now. I'm not going to try and unsolder this with a hot air at the moment. I've had enough bad experiences with these glued on chips before to have learnt my lesson. The hard way, of course. Okay, almost had it that time. Well, it's loose, so hot air should do it. Okay. It wasn't glued. Good. Other one. Okay, and I've put a dot on the PCB and I've put a dot on the chip that came from there. So that one was there. Right, let's swap them over, but I need to just clean this up a little bit first. And I'm going to solder them back on using the soldering iron. And there they are, the chips swapped over. I hope you would class that as a pretty good soldering job, actually. I'm quite pleased with that. Let's see if that swapped the fault from one side to the other. Okay. So we'll start with U4 pin 1. Switch it on. That's still going low. And still clicking on the same side. Okay. And U6 pin 7 still oscillating. So swapping the chips didn't make any difference. Let's see if U4 is effectively behaving like you would expect it to do for the various inputs, or if it's behaving strangely. Okay, so we know this output is negative. Let's have a look on either side of this resistor, although to be quite honest, because we have a capacitor here, we'll probably see the same on both sides. And we can look at output of 7 here, okay? But that looks like that only passes audio through a capacitor. DC won't pass. So, yeah, what's going on pin 2, which is this end of R34? So, one end of R34, is it this end? Goes to pin 2. Yeah, it's this end, okay? So that has 0.019. What's on the other end? The same. That's what I expect it to be. 0.019. What's on pin 3? This goes to ground, I think. Yeah, 0.002. So pin 2 is slightly higher than pin 3. So the inverted input is higher than the non-inverted input, so you would expect this to go low, actually. I mean, it's not much, but op-amps don't need much. Okay. Can't be coming from pin 7 because, well, the capacitor, but we can look on pin 7, which is here. 0.019. Slightly negative again. I'll just check a couple of resistances around here, then we can swap these op amps, not a problem. So from pin 2, we should have the feedback. So this schematic doesn't match mine because I have a 1K here. This has, well, two 2.2s in parallel, which is 1.1, basically the same as mine, and a 47, so about 48K there, okay? In the feedback, about 48K. And obviously the capacitor should be open circuit, you would assume. Okay. So from pin 2, we know it's here, to the speaker out, which is where the feedback goes. What's the resistance? 33K. So it's a bit lower than what that schematic said, but we're not sure if the schematic exactly matches ours. But that seems reasonable. And the capacitor, where is that capacitor? Well, the capacitor is between pin 7 and pin 2, basically, with the resistor in series. So pin 7, pin 2, reach 35K. Okay. Well, I'm not sure why I should read a resistance from there to there because, well, the capacitor should basically read open. I mean, obviously there's other stuff in circuit, maybe there's some other route it's all going around. There's other capacitors here though. Okay, a bit inconclusive that. I would have thought it would read open. And then, yeah, we have two diodes here going to ground, either polarity from pin 2. That we can just check. So pin 2 to ground should read in diode mode like a diode. It does, and then in the opposite direction should also read like a diode. It does. So maybe there's a leaky capacitor, not totally sure, but the easiest thing I think at this point is just to swap this one with that one and see what happens. At least it will eliminate the op amp if nothing else. And I'd also just like to try eliminate another possibility. So the chip drives the MOSFETs, and the MOSFETs also connect to this point, which is part of the feedback. So is there a problem with one of the MOSFETs causing this? Well, at least we can check them in circuit to see if they read the same as the ones on that side. So that's quick and easy. Let's do it. This one, 1.6, 1.7, looks like this one. I think obviously it's mounted the other way around. 1.7, 1.7, close. And then this one, so this is a good channel. 1.0, 1.4, roughly 1.36. And this one, 1.37. 1.0. Yeah, so they basically look the same as each other, really. Yeah, so I'd say the MOSFETs are most likely okay. Let's swap these op amps then, because it's not difficult and it eliminates something else. If the same thing is happening, then either there's some problem with one of the passive components around here in this kind of loop. It's possible there is a problem further back and I'm just not seeing it very clearly, so we can also have a look from the beginning inwards as well. But I do believe it's worth just swapping these over, A, because we can, and B, because it'll either fix it or it's one less thing we have to think about, yeah? Let's see. I'm going to add a bit of leaded solder. I've got some flux on here. Okay, there's a bit more space here, so I'll use this big chunky tip to do it. Okay, get in there quite nicely. A bit more if I can. Okay, again, I'll put a mark on this, so this is the suspicious one. The white ink came off the other one, so I'll make a little scratch mark on this one, I think. Okay. Right. I think that's scratched. Soon find when everyone's sold it. Again, I'll just warm it up a little bit. This area just helps. Heating this side actually. This one may be glued. Yeah, it doesn't want to move easily, this one at all. Okay. Got it. So it's moving. Okay, let's bit of hot air finish that one off. Slippery little beggar, but it came off. I'll put a white dot on for now and then we'll figure out if the scratch mark stayed. Let's see. Yeah, although it slid across a bit, it didn't disturb anything else. That's good. Other one. Let's try this one with just hot air and see if it's easier or harder to do it this way, okay? So I'm going to try and pick this one up in this direction rather than across the pins, because the other one was sliding around a lot. Okay, let's see. The leaded solder should melt before any of the unleaded solder around here, so nothing else should come loose. Okay, was that easier or harder? Not much difference really, I think, but there's no glue under these. So this is where the one with the white dot came from, so we'll just put a dot here so we know it's on that side. Okay, yeah, I know it's on a different chip, I just don't want the dot coming off, and I clean this up with some ISO. Okay, so there's one of them with the ST logo towards the notch. You can see just on the screen underneath, you just see where the notch is. Okay, and the other one again with the ST logo towards the notch, slightly offset to one side, that, but it's fine. Okay, let's try this again. Is it still ticking, and is it still ticking on the same speaker? Well, let's find out. So power on. Yes, it's still ticking on the same speaker. Okay, so that isn't the problem either. Now, to be quite honest, both of these chips could cause that kind of problem from what I can see. And this is why, I know almost all of you are doing this, if you want to learn to repair electronics, you have to watch videos like this. Because if I'd gone through this, found out what the problem was, and then make a video and say, oh, it's clicking, so if it's clicking, change this, because I've already figured out what it is. And then I change it and it works. You might, or some of you might get the opinion that, oh, well, I've got one that's clicking, so it must be that. And in your case, it might be something else. So you'll change that whatever and say, well, that video was useless because it didn't fix the problem. Yeah, so guys, those of you who are learning, this is the only way to learn. And for that soldering, again, yeah, I can show you how I do it. You can see how it's done. But at the end of the day, you can only learn it by practicing and doing it. And you don't want to be practicing on things like this. You want to get some scrap board and practice on soldering and soldering chips on, and keep on practicing until you can do it every time. Yeah, if you can do it 3 times out of 3 or 5 times out of 5, you're good enough. Get on to the jobs. Okay, right, enough philosophy. I still need to figure out what's wrong with this amplifier. Was that a waste of time what we've done? No, because we know that chip is good and we know that chip is good. Okay, and we've swapped them, so we know they're good on both channels. Well, at least one of them doesn't tick. Okay, the same one ticks. So that means we've either got some problem within this loop from here to here that is causing it, and it could even be one of the MOSFETs. I'm not totally convinced it is, but I'm not totally convinced it isn't. Yeah, so it could be something there, or I could have actually got this wrong and the problem is actually further back and I just didn't see it at the time. Maybe the amplitude of the click is lower or something like that. So we already had a loop here just outside the loop. I'm going to go back again, so I'm going to go to here and here. This is well out of that loop. Okay, well out of that feedback. And do we have the same problem or some difference? Yeah, let's look for some difference between U8 pin 1 and U8 pin 7. Okay, is there a difference? And I hope you would agree to some extent that this is not actually difficult fault finding, because all I'm doing is comparing things from a known good channel, or at least doesn't click, and the clicking channel. Yeah, so I'm only looking for differences. That means I don't really know what I'm going to find, but I know that the points in both circuits should be the same because they're identical circuits. Yeah, so this is not so tricky really. It takes a bit of time and it takes a bit of luck. It just depends on where you hit on first. Yeah, so there's some luck involved, of course. Okay, so U8. We can see it here. We can see pin 1. We can see pin 7. I've got no audio input, but it's this click I'm interested in. Do I see any difference at this point? the reason I don't have any audio input at the moment is because I don't need it. I've got a clear fault at the moment, yeah, as it stands. So sticking audio in isn't going to tell me anything particularly useful regarding this problem, at least. Okay, so pin 1, U8, switch on, watch the scope, what happens? Well, nothing happens. I'll turn the sensitivity up a bit. Okay. Pin 7. I'll switch it off again. I want to see what happens as it switches on because the clicking doesn't start straight away. Okay, U8 pin 7. And we get the same thing. It goes like that slightly wide thing. So there is no difference there. That pretty much tells me that whatever is coming out of this chip, audio processing chip, is the same for both channels. So back to U4 and U6, pin 7 of U4, pin 1 of U6. We were here before, but I've turned the sensitivity up a bit on the scope now, so it was also yesterday. Let's just remind, at least myself. So U6 pin 1. Just like a little signal type thing, very small. And pin 7. This is where we could see that oscillation from the chip. So it goes negative, and then it goes to that. Okay. So that one just pretty much stays at 0, and then we can see like a slight noise on there or slight signal, and pin 7 goes down to the negative rail, then comes back to the middle, and we can see that oscillation. Okay. And U4 all the way around, so 7 is the input one and 1 is the output effectively. Okay. Pin 1, so this is the one that should be like 0, then get a very small signal. Let's have a look. So it goes high, and then to 0, and it has a small signal with the clip, but it's low. Okay, interesting that. And pin 7 goes low, stays low. So we can certainly say when we look at U8 here and here, for the both channels, it's the same. They are the same as each other. But when we look here and here, it is different. And also from here to here, it's quite different. But this is where this loop thing comes in. I had a capacitor, one of these capacitors that read a resistance across it, and I did comment on it earlier. I thought it would read like open. So let's compare this. So let's go from pin 7 of U4 to pin 2 of U4 and see what we can see. Okay, and then we'll do the same on the other channel. Okay, U4 7 to U4 2 with the red on 7. Okay, which is the output from the previous op amp, reads 35.74k. So that's with the red lead here measuring to there. Okay, and I'll say there's a capacitor in this. I'm surprised I see a resistance, but let's look at the other one. So this is U6.1. This is where you put the red lead to U6.6. Okay, if it makes any difference with the polarity, by the way. So U6.1 to U6.6. Yeah, 37.4k. So I don't have much difference there. I don't think enough difference to be causing a problem. Obviously there is tolerances and components and things. So I don't think that capacitor is leaking, or it would be doing the same on both. Okay, so we've proved, I believe as much as I can, that the fault is somewhere in the loop. Here, okay, and this one. So what else? Any other inputs on this? Well, we have this. I'm not sure what this is. SD channel 1, which has a test point on it, test point 6. And SD channel 2 has a test point 7. And that, although I don't have a data sheet for this, exactly, it looks like it, well, it's an input because it comes through this transistor, so it's definitely something coming in. So let's have a look on test point 6 and test point 7. Test point 6 being the one that's got the clicking by the looks of it, the bottom one. So test point 7, let's see what this does. Assuming still this is a good channel, okay, so switch on, it goes slightly negative, and then it goes up and stops at about 8 volts, I would say. Just put the trace in the middle, so I'm on 5 volts per division. Try again. Test point 7. So there's a bit of voltage on there, so capacitor must be charged somewhere, about 3 volts. Goes down, it goes to 0, not negative. Yeah, it goes up to about 8 volts, maybe more like 10 or 12 actually. Goes a bit higher. Okay, so that's that one. Test point 6, what are you doing? Again, goes to 0. Oh! So that's different. And the frequency at which that is going up and down suggests it's to do with the same problem. Comes via this transistor. I think the transistor's working because it's kind of like doing what you'd expect a transistor to do. We can look on the base, but I'm pretty sure we're going to see the same thing. So where's Q2 and Q3? And for that matter, where do they connect to? SDCH1, yeah, I've got it. Where else does that go to? Oh! It comes out of this chip. Here, look. So we've got pin 16 and 19. So this is R520 or 521. If I can find those 100 ohm resistors, that's probably the easy place to probe. Well, the resistors are there. I mean, we know this schematic is not exactly the same as mine. There's Q3. I'm guessing Q2 is around here somewhere. But if we see the same thing happening here, we know it's the same signal, yeah? So without tracing those through, let's have a look. So this goes from the chip to the base of the transistor according to the schematic, and that was probably the same. So that one, yeah, then goes down. And this one, same thing, up, goes down. Don't see the clicks. Turn the time base down a bit. What's happening on this end? Don't see anything there either. Yeah, these signals go through the 100 ohm and then they go through another 10k here, okay? So let's just check, make sure this does match our schematic. So from these resistors to pin 16 and 19 on this chip, which is U5, which is this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 12 on the side. Okay, so just find the resistor over here. Go to continuity. That should come here. Yeah, there, pin 16, 17, 18, 19. So it matches the schematic. You can hear the meter bleeping there. Okay, so once more, R520, R521. Do we see any difference here? Switch on. Goes up and then up again. And then comes down and just goes like a little bit, like a bit of noise or something. Okay. This one, up again. and comes down and goes a little bit wider. So no, that looks the same. That's the end that comes out of the chip. Right, that's probably good news. Let's find Q2 and Q3. And looking at this, there's no other supply to these transistors, so the voltage must be coming out of the chip. So basically it could be the transistor pulling it down, but I can't see any difference on the input. Or it could be the chip giving a different voltage. I need to see if I can find the datasheet now more for this. But let's have a quick look. I'm expecting to see that the base, basically, well, it's a base, yeah. So basically is the same on both. And we see the thing going on here and here. Okay. Q2, base. This is always the base. Unless it's the gate because it's a MOSFET, but it's not. So this is the base. Okay, let's see what happens. Goes up a bit. Goes down, and we get the clicking. Okay. Q3. Let's see. Goes up a bit. Goes down, and we get the clicking. So what we're seeing on the collector, this one for example, is high, goes low when we switch on, and goes up and stays high. Yeah, it's off the screen now. Okay, and we know what happens because we saw it where this goes to from here. That's like a capacitor charging and discharging somewhere. Okay. The emitters are connected to ground. Schematic says so, so these should just read 0. Okay, so again we'll power it up, see if anything changes. It shouldn't. Yeah. Stays flat, 0. Stays at 0. And the other one, emitter, 0. Stays at 0. And I'm sure the transistors are okay, but you know, we have to test them, so let's do that. I'm on diode mode. These are NPN according to the schematic, so red to the base. There's the junction 707, and the collector base should be slightly lower. 703, and the same on this one. 702, 707, so the transistors are fine. I expected they would be, and I hope you did too, if you're following this. So what does this CSD1 and CSD2 do? Yeah, I need to see if the datasheet of a similar one I have is correct here now, because it would appear to me that whatever's pulling this down is not the transistor, because nothing's changing on the base. It's the chip itself, and yet we've swapped the chip, so we know the chip is okay. So what is that pin? And why would it do that? Do you remember that forum post I found earlier that suggested that this chip was a remarked or copy of the IRS20955S? So let's find the datasheet for that one. Protected digital audio driver. And the pin which we have doing strange things is this one, pin 2, which if it is a copy of this chip is CSD. And CSD shut down timing capacitor, reference to VSS. So this, when I said looks like a capacitor charging and discharging, seems to be the case. So why would that happen? Well, it shows there charge discharge protection control, high voltage level shift. Okay, I think this is going to tell us something useful. Overcurrent protection to protect the power MOSFETs during abnormal load conditions. Okay, the IRS20955S engages a sequence of events when it detects the overcurrent condition during high side or low side turn on. As soon as either the high side or low side current sensing block detects overcurrent, yeah, this CSD pin starts discharging the external capacitor. When voltage CSD falls below a threshold, the output signal resets and it starts charging again, and then as it says, as long as the overcurrent condition exists, the IC will repeat the overcurrent protection sequence. So I think we can say that's what's happening. Our chip, and it's not the chip, senses an overcurrent. This datasheet tells us then we have low side overcurrent sensing and we have high side overcurrent sensing. And the current sensing basically measures the voltage drop between the drain and source of the MOSFET when it's turned on. Obviously, it will have an RDS on. As we pass more current, we get more voltage across it. This is a bit like my fake MOSFET detector. So for the low side current sensing, it actually measures the voltage across the MOSFET by measuring the voltage difference between VS, that's the output basically to the speaker, and COM, which is the negative supply rail. Okay, since the voltage from VS to COM is compared to the voltage at the OC set pin, which is this, so that's set with between VREF and the voltage divider. It's set by these resistors. So if the voltage between there and there is more than the voltage on here, then it will trigger the overcurrent. Okay, that's what it's telling us. And the voltage on here will depend on the value of these resistors. Okay, so if we have a problem here, either this MOSFET is passing too much current, or there's a problem with this resistor. So effectively, if one of these resistors is high or open, maybe it will just confuse us altogether. So let's have a look to see what's going on OC set, assuming this is the correct chip. In fact, we can measure the resistance on both amplifiers, thinking about it, between VREF and OC set, or maybe we just find the resistor R4, R5, but they won't be named or numbered that on our schematic. So let's have a look at our schematic, and if our chip matches this, then OC set is on pin 7, and this looks the same, Luke. So we have pin 7, that's the OC set. We have a resistor between voltage ref and HV minus. That's exactly what the datasheet showed us. So we need to have a look to see what voltage is on pin 7 on both of our chips. Should be the same. With respect to ground, this may read negative, so don't let that surprise us. What do we have? Well, there's a negative there anyway. It's not switched on at the moment. Minus 49, minus 50. Okay, and the other one, minus 51.4. There's going to be some tolerance, and that's changing a little bit. There's going to be a little bit of tolerance in the resistors. This is the one that's clicking, and that is a lower voltage. Okay, interesting but not conclusive particularly. It could be that that's why this thing thinks it's got a overcurrent on the low side. What's also interesting is on this one, okay, so that's pin 7, and that goes here to this resistor 3301, so 3.3k. It also goes to this one 6.8k, and the 6.8k reads 6.61, and this one reads 3.23. And if we look on the other channel that isn't working, pin 7 goes, well, there's a 3.3k here. Okay, but that isn't connected to this pin. This pin's connected to this one, 4.7 and the 6.8. So this one has different value resistors. You see, 6.8 reads 6.5 and 4.7. We the other one had 3.3 reads 4.6. I find that odd as well. But it's not quite so strange, because if we look at the schematic, and bear in mind this isn't ours, it's just a similar one. This has a 6K8 and a 3K9. And that is a 5K6 and a 5K6, which are different. But you would think, I would have thought, that these channels are the same. So, go figure that one. Let's see if we can get anything more conclusive with the high side. So it says for positive load currents, high side overcurrent also monitors the load condition and shuts down the switching operation if the load current exceeds the preset trip. Okay, current flowing that way. Current sensing based on the measurement across VDS, okay, again, during high side turn on through pins C, S, H and VS. In contrast to low side, the threshold at which CSH pin engages overcurrent protection is internally fixed at 1.2 volts. So we need to be seeing less than 1.2 volts on the CSH pin. Where's that reference to? It then goes on to tell us about this blocking diode and the forward voltage drop of the diode, and the minimum threshold required for high side overcurrent is 0.6 volts. Okay. This is a typical circuitry for the high side current sensing. Looks very much like our schematic. Okay. And then talks about reverse blocking diodes. So we want to have a look to see what's happening on CSH. This one seems to be referenced to ground. Where's the schematic? It will tell us. So pin 16, this references to the output. Okay, 16 to 13. But let's have a look to see what we can see on 16. Which, being the end pin on the chip, is easy to probe. So let's have a look. We'll use the multimeter first, but I may well put the scope on as well, see what that tells us. So, okay, to here, switch on. It's clicking, don't see anything. This one. Well, this shows like a varying voltage, but that's the channel that doesn't click. Scope. Okay, the channel that doesn't click. What does a scope tell us? Goes up. Off the scale. Oh, high frequency running. And this one obviously doesn't run because the MOSFET isn't switching. Yeah, this just stays down there. Makes sense because the MOSFET isn't switching. Because there's a current protect, but okay. So we can't see anything sensible there because this one starts to run and this one doesn't. But I don't see any voltage on there. Yeah, even before it doesn't run, I see nothing. So I think I'll swap the MOSFETs from one channel to the other and see if that tells us anything. I know there's no short on the output because I measured from the speaker to ground. There's no short on the output, and in fact I measure the resistance of my speaker on the output to ground, which is what you would expect. So let's swap these MOSFETs, and while we're at it, let's test them out of circuit. They're all the same type. I will check that we have a connection through. You see these resistors? This is the gate resistor, by the looks of it, 10 ohms. Goes back to the chip. Okay, another one there. One of these resistors could be open, and that would cause the gate to float and maybe cause a problem. So I can check the resistors, but let's check the whole path. This shows different values again. Mine's a different model. So pin 10 and pin 14 are the outputs. So I want to measure the resistance from pin 10 and pin 14 to the gates. Okay, here's pin 10. This is a gate. I think this goes to this one. Reads 10 ohms. And pin 14 here, 10 ohms. Okay, they're the same with the other ones. So pin 14, gate, 10 ohms. Pin 10, gate, 10 ohms. So the gates are not floating. That's good. Right, I'll desolder these and we'll swap them over. Okay, it's all back together. Because I've done all this soldering around the output stage of this, I'm just going to put the current limiter on. You can see it over there. Okay, So I just want to make sure I haven't caused anything bad to happen. So power on. Bright then goes out, so that's fine basically. So what does it do now? Does it still click on that same speaker? Yeah, exactly the same. So we know the driver chips think there's an overload on this channel, but I can't see anything that would be causing that basically. Okay, I don't see anything there. If we look at the output on the amplifier here with the scope, then if there's some sort of overload, the voltage here should change because, well, the speaker reads the right resistance, it doesn't read short. But if something was breaking down and passing current to ground, like a capacitor or something, then that could only happen if there's some voltage here. Yeah, I mean, would you say that's like egg comes before the chicken, which obviously the egg did come before the chicken. So if we look at the junction between MOS 1 and MOS 2, and we look at MOS 3 and MOS 4 as well, so we know one of the sources connects directly to one of the drains, okay? And we can see which one with the multimeter. Yes, this one. So those connect to each other, okay? So this is speaker out. In fact, we can get through to the speaker, I would say. Okay, that reads 12 ohms. You know what I'm doing here? I'm actually reading through both speakers. It goes to this one. And then effectively the other end of both speakers are connected to ground. So I see 6 ohms and across both I see 12 or 13. That's fair enough. It goes to here. Okay, so that is one of the outputs. And then on the other side, this one, I think. Yep, goes to there and goes to one end of the speaker and obviously reads 12 to the other. That tells us, by the way, there's no short on the speaker to ground. You see the speaker. Okay, so there's nothing shorting either of them. Right. And anyway, on the bad channel, the speaker clicks. So that also tells us that. So let's have a look with the scope what's happening here, because something is happening when we power up. I know that now, so I want to show you guys. So we see this scope, okay? So I'm going to go on here and we're going to power up and watch the scope. So nothing happens, and then the amplifier starts clicking, and then we do see something, okay? And on the other channel, it goes into oscillation, okay? The pulse width modulation is running, the Class D amplifier is running, okay? Now I want to show you something else. So this is U4 and this is U6. These are the two we swapped over, okay? So if we look at U4, and I spotted this early and thought, oh, what is that? But I've had a good look at it now. Okay, so I'm gonna go on to, again, U4 pin 1 and power it up and we'll watch what happens, and U6 pin 7, okay? So U4 pin 1 is here, okay? Switch it on, watch the scope. Goes up a little bit, then you see that, and then it goes down, and then it starts to click. I'll show you again, I'll just make it a bit bigger. Okay, so goes up, then we get that, and then it goes down. And that's at a much lower frequency than that thing coming out of the Class D amplifiers, okay? Then we get the click, 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 click. Let's look at U6 pin 7, which is the other channel, same place. So U6 pin 7. Try again, watch. Goes down, doesn't do that weird thing, and then the thing kicks in, yeah? Oscillating. But the interesting thing is, to me, that whatever is causing that phony waveform here, which we saw, is not coming via this feedback, because it isn't happening here. And we can absolutely even more confirm that, because we can have a look on the power resistor, the 1K resistor, or 81 or 88, whatever it was on my board. Yeah, R81, R88. Okay, let's look there, both sides. So here's R81, bad channel. Switch on. And it's not there. Other side, switch on. Not there, okay? So that is not where that crazy waveform is coming from. It's not coming from the output of these. Okay, we can go on the other channel. This, I think we just did the high frequency. Yeah, it's just gone off the screen, that's all. It's early, okay? So that crazy waveform on power up is not coming out of here. Yeah, it's not coming out of here and round that way. So where is it coming from? Well, if we go back here, and we've looked around this chip before, is it coming from here? So this is U6, okay? And we've already swapped U6 and U4 over, so we know we've swapped these things over. Let's have a look on pin 1 of U6 and pin 7 of U4. Well, we buy U4, so we'll do this one first. This is the bad channel, pin 7, okay? Watch the scope. Goes down. Don't see any funny waveform there. Stays there. Okay. U6 pin 1 on this one. Okay. Watch the scope again. Just stays there. So this just has 0 on and this goes down to minus something, okay? Let's go back a bit further. U8. Pin 1, pin 7. Again, watch the scope. Just stays at 0, yeah? Pin 7. Just stays at 0. So the signals are the same there, which is here, that's the same. And U4 pin 7 is where it's different. There you see, negative. Less than a volt, by the way, opposed to U6 pin 1, which is the good channel. Okay. Just stays at 0. So I can't say for certain what is causing that weird waveform, but I can say that at that point it's different from one channel to the other. And I can say that that weirdness is not coming from the output of these. Okay? Why would this be different if this is the same? Well, we've swapped the chips, U6 and U4, so it's not the chip. So it's either something to do with these two resistors or something to do with the power, plus and minus. Let's have a look. U4 pin 8 should be the positive rail. We'll have a bit of voltage there anyway. Let me just power it up. Yeah, there's the 8 volts. We know we have plus and minus 8s on this. And then on the other end, there should be the minus 8. Minus 8. So the power's fine. And that's the bad channel. Okay. So the other thing is these two resistors. So R101, 102. Compare with 92, 93. Well, if we measure from pin 2 to ground and pin 2 to the pin 1, and then compare with the other one. So 2 to ground and 2 to 1. Okay. And 6 to ground and 6 to 7. Okay. 6 to 7. 1K. 6 to ground. 1K, so that's all right. 2 to ground and 2 to 1. Reach 2.6. 2 to 1. Reads 1K. And that reads 2.6. They're either different, because I don't believe for 1 minute that you have a resistor that reads low. Yeah. And we did spot some other differences between these channels as well, around the current sensing. Okay, probably because one's for the tweeter and one's for the woofer. Maybe we have different loads, different impedances. I will just make sure we don't have a broken track between U8 1 and U4 5. So U8 1, U4 5. Yeah, it's connected. That's fine. So the inputs are the same. We know we have a connection, but here is a negative and this is 0, which is what you would expect from no audio. And then this channel behaves really weirdly. So about the best I can come up with, and the only last thing I can think of trying before I need a real 4 AM moment, is this capacitor C27. Does it leak? Does that leak? Well, I can't see it marked on the silk screen, but I'm sure I know which one it is, because there's only one capacitor that goes to U47. Yeah. And that is this one. Goes to this end of it, okay? So I'm going to change it. I mean, we checked this resistance before and it looks the same on both channels, yeah? But, like, clutching a few straws here, I'm going to change that, yeah? Let's see if that fixes it. Well, I don't actually have this X5R 10 microfarads, but this is the same capacitor on the other channel. So I'm going to swap them over, okay? Okay guys, so they are swapped. Not exactly completely tidy, this one, but it's there. It's soldered, okay. Let's see if this still clicks on the same speaker. Yes. It still clicks on the same speaker. And it still does that. Okay. I'm going to call it a day on this one just now, guys. I'm not giving up on it. I just feel like I've exhausted all the things I can think of at the moment. I can see where it's different, but can't figure out why it's different at that point. Okay. We've swapped a few chips around. We've swapped capacitors around. So I've proved a lot of things that it isn't, but I still am unable to figure out what it is. Okay, so yeah, it's the weekend now. Could be a 4 AM moment. Maybe I'll think of something. Maybe you will think of something. Okay, so a very in-depth one that seems you can't always fix them all, at least not so easily. Okay, well, I hope you enjoyed that. I'm certainly going to go and enjoy the weekend, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.